Let's talk about modulation and creating dynamic sounds using synth modules. Again, this is going to be entirely in VCV Rack. This is going to get a lot of fun, and it's also going to get a little crazy, so just be prepared. Modulation makes things more interesting than the defaults. The great benefit of modular synthesis is that nearly anything can be used to modulate anything else. You take the output of X, it goes to the input of Y, it changes parameter Z. Usually a parameter that can be modulated has a control knob associated with it. It's going to be called depth, CV, amount, etc. There are some classic sources of modulation. Physical controllers. You can hook up a joystick and use that. You can hook up a MIDI controller, use knobs and faders on that. You can use LFOs, random noise sources, envelopes, and of course, sequencers. Modulation is a classic way to shape sounds, but there's also a classic way to shape modulation sources, which are using ATTENUVERTERS, which are a hybrid module that includes an attenuator and an inverter, unity modules, which sum different signals together, or you can run a modulation signal through a VCA and use an envelope to control it, and then send the output to modulate something else. That way you can pulse things and get really cool timing effects. It's fun. So let's look at the sources that you can use for modulation purposes. Well, MIDI to CV. In addition to the volts per octave and gate, you can use other parameters from your MIDI controller as modulation sources. There are 4 that you're really going to want to use more than any other: velocity, aftertouch, pitch bend wheel, and mod wheel. These give you a basic physical control over the modulation control voltage, but the pitch bend wheel and modulation wheel are generally going to be the best for most controllers. That is, of course, assuming that you don't have a separate set of pads, faders, and knobs that you can map out. However, if you do, we have the MIDI-CC device, which lets you assign the other MIDI-CC controls on your keyboard, like the knobs, faders, pads, etc. Anything that's not one of the wheels or a piano key to a corresponding output, and automatically convert that to CV. All you have to do, select your driver, MIDI device, and channel on the top 3 lines. Then you'll notice there is a 4x4 array, 0 to 15, in the display, and below that there are 16 outputs. Well, 15, 0 to 15. So that corresponds to the outputs below the display. So if you know those, you can easily say, okay, well, this is my fader. It's on MIDI-CC 1. Okay, well, I'll just go down to the one that corresponds to 1, output that, and we're going to use that for my decay time. But what if you don't know that? What if you don't know the CC number? Well, it's actually really easy. Now, you just click on the desired box in the display, and it enters map mode. So you click on it, and you move the controller on your MIDI controller, and it will automatically change that to the correct control number. Then you just hook up the cable, and you're done. It is super easy. But we'll definitely look at this in class because I love this module. Another classic source is the LFO, or low frequency oscillator. Generally, these are producing the exact same waveforms as an oscillator, but at subsonic rates, so just above 0 to 23 hertz. Although they can also typically be driven into audio range, typically maxing out around 200 hertz. Now, these can be both unipolar or bipolar signals, which is good if you need the option. Unipolar will only go from 0 to 1, but bipolar will go from -1 to +1. Very important. Do you want your signal to go both up and down, but only in one direction, and move the frequency knob from, say, 50 hertz up to 5,000 hertz and then back down to 50? Probably want to use unipolar. But do you want it to sweep from 50 down to 25 and then up to 75? Probably want to use bipolar. Now, the LFO has multiple frequency modulation inputs and associated CV depth knobs that will create really, really crazy, freaky, random, somewhat insane waveforms. We will look at this in class. Classically, you are going to use sine waves for this, but it can accept any waveform. Pulse width here controls the PWM, as does the PWM CV. Reset is effectively the same as the sync on the VCO, but can be really harsh if you are using frequency modulation. Especially if you're doing a lot of frequency modulation, this can get really, really squelchy and raw sounding, which can be cool. And like the VCO, it can output all waveforms that it produces at the same time. Random is a random source of values. This is a staple of synthesis, especially in West Coast synthesis going back to the Buchla. Essentially, this is a random signal generator with a rate and shape control that alters the waveform speed and shape. It can also be influenced by an external in source and can be changed from unipolar to bipolar output or absolute to relative values. This can get very, very interesting. Outputs are a slewed version of the resulting waveform in either a linear or exponential form. But there's a couple more interesting outputs that are not slewed. Slewed meaning that it is smoothing the values and doing a little portamento between one point and the next. More interesting is step, which converts the waveform to sampled step values, so discrete values with no curve between them, which means you could use this for maybe a random sequencer. Then you also have SM plus H, or sample and hold. This requires the trigger input, but the way that it works is that when it receives a trigger, it samples whatever the current voltage is and keeps outputting it until the trigger is released. This is really cool to pair with a noise module going into the external in. This will create some really, really random voltages, and with a decent trigger, you can get some really cool effects with it. Another really good one to use for modulation is the ADSR. The envelope generator is pure modulation. It is so commonly used for modulation that you've already been using it by using it to modulate the level of the VCA. So by default, the envelopes are unipolar. They go from 0 to +1 and not from -1 to 1. But we can invert them so that they go from 0 to -1 using an ATTENUVERTER, which we'll talk about momentarily. The envelope is a really good choice for adding extra oomph via frequency modulation, or to shift the cutoff frequency of a filter at the beginning of a note to create a slide-in effect. This is a really fun one. It can also be used on the resonance of the filter. It can be used for the pulse width modulation. Again, it is pure control voltage, so don't think of it as only going to the amplifier. It can be used for any type of modulation. Finally, we have the sequencer. This is the big daddy. Let's just get this out of the way. Sequencers output voltage. They do not output pitch, and they do not output rhythm. What you have here are 3 rows of dials, 1 through 8. Each row has its own separate output. So you can have 3 different sequences going and then change which row is outputting by changing the cable. You also have gate values. These are the individual column outputs. When a row column is triggered in a row, it outputs a gate value both at the gate output and underneath the column that has just been triggered, and you would see the green light light up into a brighter green. You can also click on those green buttons underneath each individual column to mute that particular column. The steps control controls the number of steps in the sequence. You can have anything from 1 step to 8 steps. The clock controls the internal clocking speed of the events. Run must be turned on for the clock to work, while external clock just needs pulses to change the values and go from column to column to column. Again, all of the 8 dials in each row can be set independently to different values. So you're outputting volts per octave, or you're outputting different CV from each row. You're outputting different gate values from the global gate output or from individual columns. So if you want something to only occur when column 4 fires, you would just plug it into the gate output of column 4. This is a really, really cool thing. We're going to take a lot of time to look at how to use this. But you can also shape modulation. There are different ways to take the modulation and make it even more modulated. First and foremost is the ATTENUVERTER. This is probably one of the most useful modules in modular synthesizer. On my physical modular synthesizer, I have several of these because they are so useful. It combines an ATTENUVERTER, which allows you to scale a value between 0 and its maximum in the positive range, and an inverter, which allows you to invert a value. So if it went from 0 to positive 1, you can invert it and it will go from 0 to negative 1. So here, the way that that works is that the center value of each dial is 0. It's off. Nothing happens. As you turn the dial, more and more of the signal is scaled on the positive direction. So that is output, and it goes in a unipolar 0 up to the positive maximum, whatever that value is. As you turn it counterclockwise, you go from 0 and open it up more and more until it goes to negative whatever its maximum value is. This is really cool because you can use it to invert a signal. You can use it to scale a signal. You can change it if you don't have a depth control on whatever you're trying to modulate and you want to be able to just kind of dial it in and make it a little bit finer. Use an ATTENUVERTER. Use that to scale how much modulation is going through. If there's crazy pitch modulation going outside the realm of human hearing with the frequency modulation and you've got some freakish waveform going, use an ATTENUVERTER to bring it back down into human hearing. Also, note that you can chain multiple attenuations of a signal from top to bottom as long as no other cables interrupt it on the in or out sides. This is something we'll look at in class as well, because that can be a little confusing until you see it in action. Next, we have Unity. This is a 2-channel device that takes 6 signals per channel and combines them. If you right-click, you can also bridge the top channel, channel 1, to channel 2, and have 12 signals that you're adding together. They're added together in one of 2 ways. You can either sum them, where it adds all the signals together, whatever the values are. Some of these might be positive, some of them might be negative, there might be some cancellation, it could be cool, it could be weird. Or it takes the average values of the signal at any given instance. Now, in addition to doing that, it has 2 outputs per channel. Output is just the normal result of summing or averaging. Inversion is the inversion of the output signal. So if your output signal is all positives, your inverted signal would be all negative values. This can be very interesting in its own right, and I strongly encourage you to consider that when you're using this as a modulation shaper. And again, the VCA. As I said before, this is really, really, really cool because you can use it to scale a signal, but not just audio signals. You can plug a CV signal into the input, use an envelope to open and close the VCA, and the result will be really interesting and kind of musical. This works really great with complicated sequences, like from a sequencer, using a random source, noise, or taking all of that and summing it in a Unity device, and then putting it through the input of the VCA. and outputting it to, say, the volts per octave of your oscillator. Make sure that you test your ADSR envelope, though, and make sure that it is triggering. If you don't, this can be just where the signal breaks down and you get silence. Keep in mind that you can also use a gate signal in the exponential or linear inputs to fully open and close the VCA without an envelope, but this will be kind of clicky. It can still be kind of cool, though, if you use that and have that paired up to, say, the sequencer. Just a hint. Now, what do you want to modulate to? That is the question. There are a lot of targets for modulation. Anything that takes CV in can be a target. But the classics are volts per octave, which you would modulate with sequences, random noise, sample and hold, LFOs, etc. FM, which you'd modulate with envelopes, LFOs, or sequences. Pulse width modulation, which can be modulated very effectively with anything. Effects, which can take any modulation source from whatever and modulate any parameter. LFOs can modulate other LFOs, including the frequency modulation. Hint, hint. Filter cutoff and resolution. I like to modulate these using MIDI-CC controllers in particular. I love having physical control over my filters. But they can also be very, very powerfully modulated by using envelopes, LFOs, and sequencers, especially if you're feeding those through an ATTENUVERTER. Clocks can be modulated by anything, but also other clocks, especially the clock from a sequencer. And anything else that will connect can modulate anything else. If you take audio in, you can modulate something with that audio signal. It might be very bizarre, it might be very cool. But modulation is your source for creating interesting sounds that move, that change over time, and don't just sound like sine wave. Now let's talk about the VCOs in particular. Modulation is designed for VCOs, but you can also use multiple VCOs. You've probably found that a single one is just kind of thin and boring unless you run it through delay. So remember that cables are stackable. You can stack the volts per octave going out of your MIDI to CV and put that on both VCOs. VCOs. Then you can detune one up or down to create chords. And you can slightly detune one using the fine control to get binaural beating effects where it sounds kind of like it's going out in both ears at a set interval of time. Or you can use chorusing effects if you turn it up even just a little bit more than that. In addition to that, you can use the FM input of one oscillator with very, very small adjustments on the FM CV and MIDI to CV retriggering going to sync and an LFO reset if you're modulating with FM on an LFO to create really, really freaky modulations. This is classic modulation technique. If you use the modulated VCO using a higher pitch and being modulated by an LFO or an envelope, that is classic West Coast synthesis technique. Another thing that's really cool that you can do with multiple VCOs is ring modulation. There's direct modulation created by multiplying one signal with another. That results in a mirror of the modulator's spectrum around the carrier of the fundamental. This is sort of achievable. You need two VCOs, both receiving volts per octave and outputting sines going into the unity module. Unity goes to a VCA, which is controlled by an envelope, and the cow says moo. The second VCO takes the sine from VCO1 into its FM inlet. Gradually increase the FM amount and watch it in a spectrogram until you start getting separation similar to ring modulation. Hook it to a tuner as well and use the fine tune on VCO2 to adjust accordingly, or you're going to notice some oscillator issues very quickly. But classic effect one that I definitely encourage you to experiment with. And we will definitely take a look at this in class as well.